Hey everybody, we've got a non-projector to work on today. This is a heavy amplifier. It's a SpeakerCraft BB1235. It's a 12-channel stereo amp. Each channel is heavy and gives you 35 watts per channel. This particular one was given to me because this module is not working. I believe it was channels 11 and 12, or possibly 9, 10, 11, and 12. There were some bad fuses I was told about. You can see the top is already, screws are removed. You can lift that top off, and then we can see inside. That's a transformer, obviously, and some power stuff, thermal sensor, and then you can see all those little flat back amp chips against that heat sink. And where I need to get is into here, which I think either this chip, that chip, or both of them. It was the 4 amp fuses that go here on the other side of this bridge. So I think it might just be for that chip. I don't think I counted. Did I count 12 chips? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, there's 12 chips. So maybe it's just one channel. Yeah, I'm not sure. I got to get that board out to see. And unfortunately, to get that board out, I think we have to take the whole heat sink out. I don't see how I can get that board out by itself without taking everything out. And no access through the bottom. So I'm going to have to take this all apart. So let me just get this set up a little better. Alright, so put the tripod up on the bench. And here's all the screws I already took out. Hold the case on. Got those old fuses out. So we're just going to start pulling screws. These boards have 2. There we go. And then up there's a washer. And it's on the board. So let's see. Okay, so that board's floppy. That board's floppy. That stuff all goes through there. So there's that piece of metal right there I want to take off so the board can come off, but there's screws going through it into this heat sink, so that heat sink's got to come off. And to do that, there are screws. There we go. Now you can see them. Alright, let's see if this wobbles yet. Well, got something moving. What else is holding it? Oh, I see. Yep. So these are going into the heatsink. I should have taken these out first. Yep. Alright, that's all loose. Can't tell if that'll come out the bottom or not. Let's see, this wire goes through, that's in the board. Well, let's just see if I can lift it. Oh yeah, all right. So let's unhook these temp sensors. And then, let's see that wire. Let's see. Oh, no. Oh, maybe. Hang on. Let's see if this works. Oops, one. All right, so I've got the two screws out that hold this heatsink piece in, so that'll come out. And now these amp modules are separated. I was trying not to unwire things, but I will have to cut that strap because we need to take this side out. And so let's see, let's get our audio. Come on. Come on. There we go. Power. Then amp power. I think that's control power. Preamp power maybe. And then these big ones are amp power. And then this one big one is the output. That's the output. So now, if I get that last power line out, maybe that's, no, I think that's the input. This whole module should lift out, and it does. All right, let me make some space. 3 amps in one, 1, 2, 3. Okay, so it's 1 chip per channel. 1, 2, 3, 4, 5, 6, and this is 6-channel output module right here. And it looks like each channel has 1 power supply. So that's 1 channel, that's one stereo set, that's 1 stereo set, and that's 1 stereo set. Only that final stereo set had cooked fuses, but as you can see, oh, not really. The fuses aren't black, they just kind of popped. Usually when a fuse has a dead short, it'll vaporize a little harder and leave a black mark. This one just kind of, it opened, but it did burn a lot of the wire, so it might be, might still be a bad chip. I didn't want to just replace the fuses without checking, because a couple of the measurements I did with the multimeter were questionable. So we are going to remove the screws holding that strap to the heatsink. 1, 2. There we go. There we are. And I'm going to set this out of the way. This is what we need to check. I don't see anything on there. Makes me worry. It's good. Alright, so the amp chip is an LM3886TF. I'll put a datasheet link in the description. But again, that's LM3886TF. There's the bottom. So what we're going to do is get the meter. We got that in frame almost. There we go. So we're going to compare a couple things just across the way. So I'm going to go on the other side of the fuse, which is here. So let's just go across. 0.568. So I guess I'm reading the bridge. Yeah, it looks like I'm reading the output of the bridge. See if we get the same thing. Oops. No. It's a little higher, isn't it? Let's see if we get the same thing on this channel, that high. Yeah, see, it's reading in the megs. So I feel like something upstream here is shorted. Let's go to the chip itself. Let's just compare. Let's find some pins that give us something. Okay, I'm getting 10 ohms across those two pins. 16. Come on. So it looks like this one's using the same power supply section. So I'm getting 16 ohms on that output. And 12K on that one. I don't know what pins I'm looking at, but I do know that reading something that low through it is not good. Especially there's really nothing on here that should be reading like that. There's these, I don't know if they're emitter resistors or what are they? Brown, black, black, 10 ohm. Yeah. Yeah, those are good. But I'm pretty sure these two are bad. Let's just check some more spots on them. You know, let me get the data sheet. That'll make this all make more sense. Okay. So, if you want to pause that and save it, go for it. So that tells us pin 1 is VCC, or V positive. Pin 4 is V negative. Pin 5 is V positive. Then we have VN positive and VN negative on 10 and 11. So let's see, 1, 2, 3, wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. All right, so output's pin 3, 1, 2, 3. So let's go across there to pin 7. 1, 2, 3, 4, 5, 6, 7. All right, so from ground to output, I am reading a capacitor. That's good. Oh, actually, no, wait a minute. 1, 2, 3. From ground to output. Oh, wait, there it goes. Yep, reading through a capacitor. All right, so ground's pin 7. 1, 2, 3, 4, 5, 6, 7. Yep, that's good. So pin 1, reading through the capacitor, that's good. So let's see, 9 and 10, that's these guys. So let's see, plus and minus. I'm getting 6.3 ohms across it. That's not good. What am I getting on the other channels? just charging up capacitors. That's good. But this one, not so much. I'm going to pull these chips out and we'll check it again. There we go. I got these removed. That was tough. But let's see what we get now. So if I go across here, it should be just counting up there. That's what we compare to a known good channel. Here we go, and it's counting up. Let's see. So that's pin 1. Alright, pin 2 is not connected. Pin 3 is output. Counting up. Pin 4 is V negative, which is here. And then V positive. Good. We have not connected. Wait a minute. 1, 2, 3, 4, 5, 6, 7. Ground, right? Okay, that's good. Then mute is 8. No idea what that's connected to. And then 9 and 10 are V in. Or audio in, I guess we should say. And then 11's not connected. So now that board shouldn't be popping fuses. Let's just compare these two guys and see how they read. So again, the same thing. Let's check output is pin 3. So pin 3. And then ground is pin 7. 3, 4, 5, 6, 7. Well, that's all right. Let's see, 1, 2, 3. Let's see what we get on this one. Aha. So we have one bad chip, not two. So this chip, I'll show you, will go from V positive to output 20 ohms. Now let's see what we get when we go to ground. 1, 3, 5, 7. Yeah, it's pretty high. Let's check from output to ground. Yeah, so from V positive to output, we have 20 ohms on this chip. On this one, which is probably okay, you can see we're in the meg ohms. So that one's bad, that one's good. So what that means is one of these is going to go back in. Come on. And then, oops, one back in and then order another, as well as some fuses. I don't have any fast blow fuses of that type around. Hey everybody, welcome to part 2 of fixing this amplifier here. We have the chip in. I'm going to install that now, and we'll put the amp back together. So I'm going to flux the top just to get those through hole vias ready, those through hole pads. And then the bottom. That looks good. Now let's get the extra flux cleaned off. Alright, now we can start putting it back together. I like it. I have some new heatsink paste for these as well. So let's go back to the amp. First step is to reinstall the board to the heatsink. That's using this here. In fact, let's try. Alright, you can see those little clips go in there. Make sure I got the right screws. Yes. All right. There we go. All right, let's get So that's being difficult. Let's try it this way. Okay, let's see if we can do this without it falling apart. Get the bracket lined up. Alright, that's ready to go back in. Alright, so bolted half the heatsink back on. This is what's going to connect it to the other heatsink. So let's bring the beast back into position. That stays in the middle. That all stays in the middle. I'm wondering if I should... Yeah, maybe I should. Deciding the best way to start reattaching all of these. Probably... Those are threaded, so start with those. Then I'm going to put these in. These go up into the heatsink. Alright, so I'm pretty sure it's these guys. Yep. All right, that's good. So I put the heat sink in and neglected to set this temp sensor where it needs to be. Oh, good. All right. There we go. I just have to put some fuses in, and this thing will be ready to turn on. I think, just for the heck of it, let's put fuses in from another channel. That way we can at least make sure it turns on. Oh, and I still have a power wire, big power wire to seat. Or I guess this is a speaker out wire. Yeah, let's speaker out. There we go. Still have protection on 11 and 12. That's weird. Wait a minute. That's just heatsink goo. Alright, so amp block is reinstalled, wires are reconnected, replacement fuses have been installed. I also replaced a lot of the heatsink compound with fresh heatsink compound. I do want to clean the dust out of this a bit. It's pretty dusty. But before I go there, let's get some power to it and see what happens. The amp chips that I put in should take care of it. I did replace two LM3886s because they are mono. There's a part of the data sheet, you can see it just has one output on it. There's a sample circuit for an 8 ohm load. So what we should get after I turn this on is just a green active light. Before we had protection on channels 11 and 12. So let's see what happens. Nothing. What did I forget? Oh, I have to turn on the power strip. That makes it work better. There we go. There we go. No protection on any of them. And let's do a DC check. Sure you can see that. You can. All right. DC on channel 12. Nope. Channel 11. Nope. We'll just go down the line. They should all be fine. Yep, all good. I use my banana plug probes, because then I can just plug it right in and get a good connection. Cap them back off. So this is good. Next thing I need to do is just kind of clean out the dust and then put the top back on. Alright, so it's now nice and clean inside. Got all the dust off that transformer. Just tuck that wire back down there. You can see it's all ready to go. And I just got to put the top cover on. And of course we will try it one more time after the cover's on. I'll have to wipe that top cover down too. But let's get those screws back in first. Nope. June 2006. Alright, there's the old parts. There's the old parts right there. Two LM3886 TFs. Now, there we go. There we go. That is how you repair a SpeakerCraft model BB1235 12-channel amp. If you have protection on a different channel, just pretty much order these in the pair. I would recommend that. I ordered one at first because one of these seemed to check out, but then once I put the one in, I saw that it was still putting out 30 volts, so I just changed both of them to be sure. And sure enough. So, change them in pairs to be safe. They're cheap, or reasonably priced, I should say. And then the fuses. So that's it. As always, thank you for watching.